Okay, so a couple things. First up, don't forget tomorrow, not tomorrow, excuse me, we moved your test from tomorrow to Friday. We're going to go ahead and take today to continue practicing. We'll do the same thing tomorrow. In fact, I'm thinking what we'll go ahead and do as far as the homework is concerned, tomorrow when you come in, we'll go ahead and look at different problems together. We'll get some few folks up here, and then we'll go ahead and turn that in as a participation grade. Okay, go ahead and make sure we get all that turned in, get some practice before the test on Friday. So it's going to cover evaluating the trig functions on the unit circle, which was what we were currently talking about. It's also going to have arc length. What was that formula? S equals R theta, where theta is in radians. Very good. It's also going to talk about area of a sector. So area equals 1/2 radius squared times theta in radians again. Very good. And it's also going to have circular motion, the angular and linear velocity. Okay. Now remember, we always start with number of revolutions over time. And then if we want angular, we multiply that by 2 pi radians over 1 revolution. The revolutions are the first to cancel out. Yes, very good. Okay. Let's see. We talked about the unit circle project yesterday, so the folks who were not here, I went ahead and gave that material to, so if you have any questions, please let me know. There is additional practice on the website using reference angles and just evaluating trig functions on the unit circle, so we can go ahead, maybe tomorrow if we have time, take a look at that as well. Has anybody had the opportunity to look at that? Okay, that's okay. It's still there. Anytime you're have a few minutes, go ahead and take a look at that. But I think that's everything I have right now. We're going to continue the happy minutes, test Friday, and then next week we'll push into our next unit, law of sines and cosines, and see how far we get. Okay. So let's see here. Where did we get? Let's do a little review. Here was our unit circle. We've talked about the patterns. Now we're moving away from opposite, adjacent, and hypotenuse. We want to go ahead and give the ratios in terms of the vertical distance, the horizontal distance, and the length of the radius. So sine is y over r, cosine x over r, tangent y over x, and then the reciprocals will follow suit. And we're getting accustomed to every point that we're going to find on the unit circle is in terms of cosine and sine. If you're evaluating a trig function and it wants the cosine of something, you're just looking for the x value. If you want the sine of a angle measure, whether radians or degrees, you're looking for the y value. If it's one of the other 4, we'll just take those ratios. How far did we get? I know we talked about quadrantals, we did the reference angles, and I think we got right into it, didn't we? We started to go ahead and determining these. How far did we get? Did we get cosine of 4 pi over 3? Okay, let me do this. Whoop, forgot to erase this from the previous class. So if you'll bear with me for 1 second, we'll go ahead and review a couple of those problems, and then we'll go back and look at some of these word problems here. Okay, here we go. Okay, so let's go ahead and do this. Now I'm going to need to use this one right here because it's the closest one. Okay, so this is at the very end of your packet, but we do have a couple of extra problems, and I got some more I can go ahead and give you. We're going to kind of skip around a little bit today just for the purposes of our review. Now this right here, it's talking about a particular key concept. I'm not too worried about it. It's more so going to come up when we talk about the graphs of these functions. So I'm going to kind of go past that right now. Let's just go ahead and look at some of these problems. Find the exact value of sine 7 pi over 6. Okay. So does everybody see where in the notes we are? Okay. And I do have extra copies over there by Adolfo if anybody does need one, or I could probably lay my hands on one. So we're on this problem here. Find the exact value of sine of 7 pi over 6. So we're going to need a unit circle to help us out with this. So I want sine of 7 pi over 6. Well, the first thing we got to do is locate 7 pi over 6. What quadrant's that in? Okay, there we go. It's in the third quadrant. Here's 7 pi over 6. So that means we're going to rotate from standard position all the way over here. So this right here is my terminal side. So wherever the terminal side stops, we're going to go ahead and locate an ordered pair, right? We have an x and a y value there. Well, remember, what does sine want? Sine simply wants the y value. So what's the y value of that ordered pair? Negative 1/2. And that's it. You use the angle or the radian measure to go ahead and locate the correct ordered pair, and then from there, the trig function tells you what it wants you to do. Like, let's go ahead and stick with 7 pi over 6 for a minute. Okay. We know that the ordered pair is a negative square root of 3 over 2, negative 1/2. Let me erase this. And we just found that sine of 7 pi over 6 was a negative 1/2, right? Okay. Well, let's say I were to ask you for the cosine of 7 pi over 6. Okay. Yeah, then all you need is the x value. Cosine simply wants the x. Sine simply wants the y. So the x value of this coordinate would be negative square root of 3 over 2. So if you're just asked for cosine and sine, you're just looking for the x or the y value. Now, if you want the other trig functions, that's when those ratios are going to be real important to you. For example, let's say I want to know the tangent of 7 pi over 6. Okay. Well, think back to those ratios we just had. What was tangent's ratio? It was y over x, right? So y divided by x. So it's not as straightforward as cosine or sine where I just list the value. Here, see, tangent is telling me specifically what to do with those. So I'm going to take the y value, which is negative 1/2, and I'm going to divide it by the x value, the negative square root of 3 over 2. And then here, to get the answer, we just have a little bit of algebra. In fact, what happens when you divide by a fraction? You multiply by the reciprocal. So this would be negative 1/2 times negative 2 over the square root of 3. So the two negatives are going to give me a positive. These twos cancel. So it looks like I have 1 over the square root of 3, right? But then there's always something we want to do with those. Okay, we want to rationalize it. So I'm going to multiply by square root of 3, square root of 3. So what should my final answer be? Square root of 3 over 3. And there you go. Just like that. Okay. Now the same is going to apply to all of the other trig functions. If I wanted cosecant of 7 pi over 6, well, remember his ratio is to take the radius over what? What's the cosecant the reciprocal of? Sine, and sine always wants the y. So it would just be r over r. Now, in a case like this, if it does give you r, what are you always going to put in for r? 1, because we're on the unit circle, so it's always 1. If I wanted secant, okay, I would take 1 over x. Okay, so let's try another one. The next one we have here, it says cosine of pi over 3. Okay, so I'm going to come back over here to my unit circle. I want the cosine of pi over 3. Well, if I have the unit circle, then I know exactly where pi over 3 is. What quadrant? Okay, he's in the first quadrant. So here, after I rotated pi over 3, this is where my terminal side would stop. This is the ordered pair that I'm very interested in. But remember, what does cosine want? He just wants the x value. So the cosine of pi over 3 would be, okay, what's that? 1/2. So the cosine of pi over 3 would simply be 1/2. See, the trig function tells you exactly what to do when you get there. Now, if I wanted sine of pi over 3, what would that be? Genevieve? It just give you the y, which is the square root of 3 over 2. Okay. If I wanted the tangent of pi over 3, then I would take the y value and divide it by the x value. Does anybody want to see that? Okay. So let's do that one. So the tangent, and I should do it down here so I have more room. The ordered pair is 1/2 square root of 3 over 2. Okay, so 1/2 square root of 3 over 2. Remember, we're looking at pi over 3, right? Which is 60 degrees. All right, we already know that the cosine of pi over 3 gave me 1/2. The sine of pi over 3 gave me square root of 3 over 2. Now if I want the tangent of pi over 3, that's going to be to take the y value, the square root of 3 over 2, and divide it by the x value, 1/2. Now this one's actually going to be nice to us. We don't have to worry about rationalizing. And what's that rule again? I always forget. You divide by a fraction, you multiply by the reciprocal. So I'm going to multiply by 2 over 1. The 2's cancel, so the tangent of pi over 3 should be the square root of 3. Okay, yes, sir? Oh, because, I mean, you can multiply it by 2, but I think it's easier for a lot of folks if you keep it as a fraction so that you can actually see, you know, what you're multiplying. Okay. But you don't have to do that if you don't want to. There you go. And then if I wanted cosecant of pi over 3, it's going to be the exact same thing. Now, one thing I want to go ahead and show you, a lot of these are being given to me in radians, right? Let me go back up here. What if I said I want the cosine of 60 degrees? Okay, but you'll notice pi over 3 and 60 degrees are the same location. So it would still be 1/2. See, it doesn't matter if it's given to you in degrees or if it's given to you in radians. So if you are given a radian measure that you're having trouble with, maybe we could simply convert it to help you figure out where you got to stop. Okay. Let's try another one. What's this last one right here? It says tangent of 4 pi over 3. Okay, tangent of 4 pi over 3. So I'm going to come all the way back to my unit circle. All right, so first off, where's 4 pi over 3? It's in the third quadrant. Okay, so we always start in standard position. I rotate all the way around. So here's my terminal side. There's 4 pi over 3. So this is what I'm looking for. Okay, I want tangent of that location. All right, so let me go ahead and give myself a little bit of room here. All right, so tangent of 4 pi over 3. So what am I going to do? What was tangent? Yeah, it was y over x. So I'm going to take the y value that I have, negative square root of 3 over 2, and divide it by the x value, negative 1/2. So this one is really similar to the previous one we just did. I'm going to take negative square root of 3 over 2 times negative 2 over 1. Well, the 2's are going to cancel. The negatives cancel. So again, I still get the square root of 3. Okay. Let me go ahead and give you just some random ones. Let me give you 3, and let's see how we do with them. Okay. So on the unit circle, let's say I want, the sine of 11 pi over 6. Let's say I want the secant of 5 pi over 6. And let's say to finish up, I want the cotangent, whoa, that was a flash, of, let's say, 2 pi over 3. Okay, and that's a 6 right here on the first one. Okay, so let's try these. Part of this is going to be on your exam coming up Friday. Now, let me make sure once you find that location, then you just do with the ordered pair what the trig function tells you to. So let's make sure that everybody's on the same page. And then I'll give you a little more time. What does sine want? Sine wants the y. So I'm just looking for the y value at that location. What does secant want? What's his ratio? It's 1 over x. Now in your notes, remember the ratio is going to say r over x, but since we're on the unit circle, the radius is 1. So I'm going to put whatever x value I find at that location below 1 and then just simplify. And then what does cotangent want? Well, he wants x over y. We've seen tangent a lot today, y over x. Cotangent wants the x divided by y. Okay. So let me give you a little bit of time to go ahead and try those out, and then we'll all see how we all did. Is anybody stuck? Does anybody need help? Brett. Mm-hmm.
On a sign for 11 pi over 6.
Okay.
It's right here, and it wants the y, and so it's negative 1
That's it.
half. Whatever it wants. 1 over x. So it's going to 5 pi over 6,
Which is where?
Right here.
Uh-huh.
And so it wants
So I want
this
to take 1 and put it over that x value, and then just simplify. There you go. You're getting it. Okay. Good, good, good. Yes, sir. Oh, okay. Yeah. Let me, if you're having trouble seeing that, let me go back up to the top here. Okay, there we go. Uh-huh. And that reminds me, Brandon M had been asking me about those unit circles. Okay. And I did get those copied today, so let me go ahead and pass those out. But I notice everybody is really using their green one that we started with, and that is fantastic. There we go. But here is a complete filled-in unit circle for you. Now remember, what can you always do on your quizzes and tests? You can always use your notes. Okay, so that unit circle is probably going to be really important to you. Okay, there we go. In fact, what is today? Wednesday, so I'm going to go ahead and put these extras over here in Wednesday's. Yeah, a different one? There you go. Was this one just folded, or what was it? Okay. There we go. All right. Cool, 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 cool. All right. Now, you may not be completely done, and that's okay. Okay, no problems. Let's go ahead and start taking a look at these, though. Where is 11 pi over 6? What quadrant? Okay, it's in quadrant 4. So here is 11 pi over 6. So I'm very interested in that ordered pair. Remember, what does sine want? Just the y value. If it's cosine or sine, you don't have to do any algebra. So the y value is negative 1/2. That's the value of sine of 7 pi over 6. How many people got that right? Okay, good, good, good. Okay, let's try the next one. Secant of 5 pi over 6. Okay, so where's 5 pi over 6? What quadrant? Okay, so it's in the second. So here's 5 pi over 6. So I want this ordered pair right here. Now remember, we already gave the ratio. Secant was 1 over x. So I'm going to take 1 and put it over this value right here. Okay, so let's see. 1 over the negative square root of 3 divided by 2. So now what? Okay, so Alize says the reciprocal. So this would be negative 2 over the square root of 3. Because 1 times anything stays the same, so we don't have to worry about the 1. But then now we have to rationalize it. So I'm going to multiply by the square root of 3. So it looks to me that the secant of 5 pi over 6 should be negative 2 square root of 3 over 3. How many people got that right? Okay, so not as many hands, but what can I do to help? Absolutely, absolutely. Okay. Does anybody think they have the cotangent of 2 pi over 3? Okay. You're saying negative 1/2? Okay, well, let's take a look. Let me go ahead and erase this real fast. So this was negative 2 square root of 3 over 3. Okay, now Christian says we have the answer for cotangent of 2 pi over 3. So first off, where is 2 pi over 3? Okay, it's in quadrant 2. Okay, so here's 2 pi over 3. Here is the ordered pair that I want. Okay, so what does cotangent want again? I always forget. It wants the x divided by the y, right? So I'm going to take this x value and divide it by that y value. So negative 1/2 divided by the square root of 3 over 2. Would everybody agree? And then now we just take care of it. So dividing by a fraction is multiplying by its reciprocal. So see, the 2's are going to cancel. So it looks like I've got negative 1 over the square root of 3. Now what? Rationalize. The square root of 3. So it looks to me like the cotangent of 2 pi over 3 should be negative square root of 3 over 3. How many people got that one right? Okay, good. Okay, now what can I do to help? Hey, Brent. We did divide, yes, because this was my negative 1/2 was the x value, and square root of 3 over 2 was the y value. If we go back up here to the ordered pair, see, I took those values from the ordered pair and divided them like cotangent told me to. Okay. All right. So Brandon wanted to go ahead and do another secant. Okay. So somebody give me a measure. Well, on the unit circle. 3 pi over 2. Okay. So 3 pi over 2 would be right here, so I can go ahead and keep this. I want the secant of 3 pi over 2. Is everybody ready? Now remember, what was secant again? I forget. That's 1 over x. So we want to take 1 over the x. Well, here, I'm going to go ahead and put 1 over. Well, what's the x value of that coordinate? 0. But what's the one thing we can't divide by? Can't divide by 0. So this one will not have a solution. And sometimes that'll happen. Okay. But now let's go ahead and stick with this quadrantal, 3 pi over 2. What would the sine of 3 pi over 2 be? Yeah, negative 1. Remember, it just wants the y value at that location. So negative 1. What would the cosine of 3 pi over 2 be? Yeah, that's 0. Okay. Now, take about 30 seconds. Try these. Try the tangent of 3 pi over 2 and try the cotangent of 3 pi over 2. So we're evaluating the trig functions all at the exact same location. Okay. In fact, this is what your next happy minutes is going to be. Okay. I'll give you either a degree or a radian measure. Once you locate it, you'll go ahead and find me the ratio for all 6 of the trig functions. And I believe that'll actually happen tomorrow because your test is on Friday now. Okay, so there's 3 pi over 2. There's the ordered pair I'm focused on. Okay. Well, what was tangent again? I keep forgetting all this stuff. Remember, it's always y over x. So I just want to take the y value, negative 1, divided by the x value, 0. But what's going to happen tangent of 3 pi over 2? No solution. Can't do it. But cotangent 3 pi over 2, remember, he is x over y. So the x value being 0. The y value again being negative 1. But what's this one? 0. You can divide 0 by a number. You just can never divide by 0. How many people got those right? Okay, good, good, good. I am starting to see more hands go up. Okay. Are we starting to feel more comfortable with evaluating trig functions? Okay. All right. Well, do you want me to go ahead and give you one more, or are we ready to move on? Another one? Okay. Let's try. Let me throw you a curveball here. How about, and let's do another secant one. Let's do secant of 10 pi over 3. secant of 10 pi over 3. Now, what was secant's ratio? 1 over x. So all I have to do is find the correct x value, and then it's just algebra from there on. Okay. But 10 pi over 3, this isn't one of the ones that is directly on your unit circle, so we're talking about a coterminal angle. It's going to stop at one of these 16 locations. That's the trick, finding out which one. Now, if it's an improper fraction like this, what was my suggestion? Rewrite it as what? A mixed number, right? What would 10/3 be as a mixed number? Okay, so this would be the same as 3 and 1/3 pi, right? Would everybody agree? Okay. Now remember, think about your unit circle. Half of a revolution is pi, right? So here, there's 1 pi. There's 2 pi. There's 3 pi. Now, I just want to go an additional 1/3 pi. So where's that going to stop me? Would it be at 7 pi over 6, 5 pi over 4, or 4 pi over 3? It's going to be 4 pi over 3. It's going to stop me right here. Okay. And that's the nice thing about the introduction to the unit circle. We have to stop at one of these 16 locations. It's got to be one of these. Now, if you're having trouble figuring out, okay, how much further to go ahead and rotate, well, think about it. We rewrote that as 3 and 1/3 pi, right? Is everybody okay with the 3 portion? Well, I did 1.5 revolutions. Okay, so we took care of that, but we have to go an additional pi over 3, right? Well, the circle is completely symmetrical. So if I were to start here, that would represent pi over 3, right? So you just want to go the exact same distance here. Okay. So after the 3, I just rotated an additional 1/3 pi. Now, all I got to do is use that ordered pair to get my answer. Is everybody okay with this? Okay. So secant, he did want 1 over x, right? So I'm going to put 1 over, what's the x value? -1/2. So it would be what? It would be -2. There you go. Okay. You want me to give you another one like that? Okay. Now you decide the trig function. I'll give the radian measure, but you decide the trig function. Do we want sine, cosine, tangent, or the reciprocals? You want sine? Okay. Then let's say sine 29 pi over 6. Sine of 29 pi over 6. So let me write this up here. Sine of 29 pi over 6. Now, my first thought would be to go ahead and rewrite this as a mixed number. But remember, when we created the unit circle, we did count by fourths and sixths, right? So all you'd have to do is just keep counting around until you get to 29 sixths, if that's how you want to do it. But let's see if we can figure out where everybody's going to stop. If you can just figure out where to stop, which of those 16 points I'm referring to, then it's just algebra from there on. Okay. So what is 29 pi over 6 as a mixed number? How many times will 6 divide into it? 4, right? So 4, and we have a remainder of 5. Okay. All right. So let's see where we're going to stop. I'm going to start here, always in standard position. So I need to go 4 pi first. So there's 1, 2, 3, 4. So the 4 just got me right back around to where I started. But now what? I have to go an additional 5/6 pi. So it stops me right here. How many people was able to find that particular location? Okay, not bad, not bad. Now remember, what does sine want? Sine wants the y value. So what's the y value at that point? That's it. Okay. Now we'll go ahead and practice this again tomorrow. There's just a few other things I want to go ahead and show you. To end today, I'm going to go ahead and show you this, because a lot of times it's going to be really useful to us to figure out in what quadrants the trig functions are going to be positive. So if you're thinking about your xy coordinate plane, if you just think this sentence, all students take calculus. If you think about that phrase, all students take calculus, the first letter of every word is going to tell you what trig functions are going to be positive there. Now, the one exception is A, because that does stand for all. So all 6 from sine all the way to cotangent are going to be positive in quadrant 1. What do you think the S stands for? Sine. Then this would be tangent, and C would be cosine. Now, the good news is wherever a trig function is positive, its reciprocal would also be positive. So if sine is positive here, so is cosecant. What's with tangent? Cotangent. And what's with cosine? Secant. And here's also something that's really useful to me. Like, for example, I know that sine is going to be positive in quadrants 1 and 2, right? And that kind of makes sense because he's the y value. Now we also know where he's going to be negative. If he's positive in 1 and 2, then sine has to be negative in 3 and 4. Okay? Just remember, all students take calculus, and we'll do a little bit with this tomorrow. Perfect, 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 perfect. Okay, thank you so much, guys.